Continuing in section 4, which is the basic rules of algebra, we're here on page 2, and the next set of problems use the instructions that say use the commutative property of addition to write an equivalent algebraic expression. So let's pause for a minute, and we're going to look at the book's definition because he does a really nice job of just putting into basic terms for us here. The commutative property of addition means that it has that root word commute, which many of us experience some sort of commute to get to and from school, possibly even to and from work, and all the other places we go. In other words, we go the same route there and back, there and back, there and back. That idea that you can reverse the order of something and it still has the same value. So in math, you can do that with both addition and multiplication. A plus B is equal to B plus A. A number example of this would be like 3 plus 5 is equal to 5 plus 3. It also works with multiplication, where you have A times B. You can rewrite that as B times A, for example, because up here, you know, they both equal 8. Well, we could do 3 times 4. That's equal to 4 times 3. We can reverse the order because they both equal 12. You may have learned them as fact families or something like that, fact triangles or something in elementary school. Now, why do subtraction and division get left out? Well, that's why I wanted you guys to start retraining your thinking. Instead of seeing something minus something, think of it as plus a negative. So while we can't say, let's do 6 minus 7 is not the same as 7 minus 6, right? You can't just switch it around the actual subtraction sign. However, if you think of subtraction as really adding the negative, in other words, 6 minus 7 is really 6 plus that negative 7. We did that on the previous page with the terms of an expression. Then you can switch that around now, but you just keep the negative sign with the original number it came with. Negative 7 plus 6, okay? Same thing with division. It's not that it doesn't work with division, it's that you have to understand what division is. Division is really multiplying by the inverse of something. So if we have, let's see, let me think of a good example here. Well, we'll take the fact family here. Let's do 12 divided by 4. Because we know that answer should give us 3, because 3 times 4 would give us 12 here, okay? But we can't turn around, because we know this one would be 3. We can't turn around and say 4 divided by 12. That's a reversal of that. This actually comes out to be 1/3. 4 over 12 reduces down to 1/3. Up here I should say that 6 minus 7 is negative 1 and 7 minus 6 is positive 1. Okay. But because division is really multiplying by the reciprocal, and some of us weren't told that until we got to fractions, and we thought it was this exclusive fraction thing, and it started to mess up our world here. But really, from the beginning, division has been the multiplication of the inverse. In other words, 12 divided by 4 is really 12 times 1/4, okay? Because then it would be 12 over 1 times 1 over 4, which when you would cross cancel or whatever, you would end up with the same answer of 3. Well, once it's in multiplication right here, I can go ahead and perform the commutative property here. It's no longer written in terms of division. Now the commutative property applies because it's multiplication. I can go 1/4 times 12, and that gets me the same answer of 3, okay? So the commutative property works across the board as long as you're thinking about addition really being subtraction really being added to the negative, and division really being multiplying by the inverse. Let's do some examples. Now, if that kind of rocked your world a little bit too much today, no problem. You will get through just fine by understanding that in addition, you can switch things around, and in multiplication, you can switch things around as well. So let's do number 10 together. Again, it asks you to use the property to write an equivalent algebraic expression. So in other words, we're not going to change the value. We're not trying to solve anything. Okay. In fact, this will have kind of an unfinished feel to it. All we're doing is practicing switching places. Okay. Just rehearsing the switch. So we identify where that plus sign is or where the multiplication sign is, and then we switch places. We switch around the addition or switch around the multiplication, and in this case you'd end up with 9x plus 4. Okay? It doesn't make this more right than the top one, they're just equivalent to each other. Okay? So this is an equivalent expression as the first one. Okay? These two are equal to each other. And the reason why we're doing this is because as we move into algebra, we're replacing numbers with letters. Okay, that's the whole point of algebra, which means that some of the numbers are not going to be known to us. They're going to be mystery numbers. When everything is a number, we just apply order of operations and do what we need to do, and we come up with our answers. When we don't know some of the numbers, at some point we're kind of stuck and we can't really do anything with the problem. So then we apply what we know works with numbers, the commutative property of addition, multiplication, so we can move things around and then continue our work. So that's why we practice these things. Let's look at number 14. Again, we're applying either the property of addition or the property of multiplication, both of them being commutative. So in this case, we've got 6 times x plus 4. So we want to apply the property, oh, I'm sorry. I jumped ahead of myself. The bottom examples that we'll do will be multiplication. And I'm realizing I should check to see if I'm still on the page. Barely. We're on. Yeah, we're on. It's the try problem that won't show up, so we'll do that on the next video. Okay, sorry about that. So we're still doing the commutative property of addition. So we're focused on where is that addition sign, and we're just going to switch around the two terms that are being added together. So we end up with 6 still on the outside of the parentheses, and it just becomes 4 plus x on the inside. Okay, and those are equivalent there. All right, and we'll have you try one at the beginning of the next video, the bottom of the page.